All right, so formula, I guess this is the second formula that was not given to you, mass divided by volume. I will tell you, just to keep this in the back of your mind, for this class, you'll most likely use this formula to find the mass of an object. That'll be in the shape of a sphere, a rectangular prism, a cone, a pyramid. You'll probably use this formula most likely to find the mass of something. All right. Also, is it going to be possible every single problem that I write the word "this is the density"? No, I won't. How can you recognize it that I'm giving you the density without the word next to it? Mass, so grams, pounds, kilograms, anything that's with weight, divided by cubic units, which we know is volume already. So if you see that in a problem, oh, they're giving me the density, even though the word density may not be on there. Last thing before we hit up an actual problem. You may have not even realized this because you're looking at the bottom of the formula sheet, but at the top of the formula sheet are a bunch of conversions. If I do not give a conversion to you in a problem, it's probably because it's on the reference sheet for you. Okay? So if you're wondering, ooh, kilograms to pounds, he didn't give that to me. It's probably on the formula sheet. Okay, really the only thing I don't provide is probably inches to feet because that's a known one, but everything else, either the reference sheet will give you or I'll provide in the problem. All right, you ready? Ready to go? Also, we're going to do this today and tomorrow. These are all not density problems. I threw in a couple of volume word problems in there too that we've been doing. All right, so this is not all density. I threw a couple of volume word problems in there that have nothing to do with density. All right, so I tried to start off with a basic one. All right, an old Regents question that I consider was a basic density problem. We got a cube, AKA a square prism, right? Cube, square prism. Each edge is 6 centimeters. That's how much it weighs. What's the density? And then after we find the density, what must it have been made out of? What type of wood must it have been made out of according to its density? All right, here we go. Let's go. Talk to me. I got density. Mass divided by volume. I was already given one of those. Mass, volume. Which one do I already know? Woo! I will call on a couple people here first. 3. Omni, which one am I already given?
You have mass already.
Mass already. So density equals that 137.8 grams over, all right, here we go. Let's find the volume of the cube here. Volume of my cube. This is where this unit comes into play now. How are you going to find the volume of the cube? 2s. Hannah, how do you want to find the volume of the cube? I need help. Not here. All right, let's keep trucking then. Just stop my mojo right there when somebody's not here. Owen, help find the volume of the cube for me.
It's length times width times height, so it's 6 times 6 times 6.
There you go, 6 times 6. And what'd you get?
216.
There you go. I got 216 centimeters cubed. Perfect. So divide by 216. The density of this cube, round to the 1,000. 3 decimal places. So look at that fourth number and see if you have to round or not. 3 decimal places, nearest 1,000. Density, 0.0638 grams mass divided by volume, cubic centimeters. So there's your density, part 1 of the problem done. And then what type of wood is it according to the table? This cube is made out of 0.638. That must be an ash cube, huh? Not a tray, a cube, never mind. Not that big of a deal, right? Anybody at home? Questions, comments? All right, let's start open up our mouths. I really don't want to call out numbers here. All right, I want to hear from you guys, even at home. Unmute yourself. All right, this class is pretty good at just saying what's on your mind without being called on, which is a good thing. All right, we got our house. We're going back to BTUs. This is a little bit more complex than the one you had for homework the other night. All right, so I see the room. It's a whole room there. That's not a house, that's a room. It's all open, no ceiling. And we need 2.5 BTUs per cubic foot of airspace. And then I throw on a little addition there. For every window, throw in 1,000 BTUs. So how many are we going to need total to cool this room? All right, everyone see the conversion I have given you right here? 2.5 BTUs for every 1 cubic foot. Cubic foot, so I know we're doing volume. All right, here we go. Let's talk here. What do I have on the bottom here? Prism. What kind?
Rectangular.
Okay, I got a rectangular prism on the bottom. So I'm going to have to find the volume of that one. And what the heck do I have on top? Ami, let's go.
Triangular prism?
I got a little triangular prism on the top. I think they both have the same formula, BH. On your formula sheet, any prism, BH. We're all good. All right, on the bottom, rectangular prism. Rectangular prism, anybody at home want to take that? Rectangular prisms are always the easiest, right? Length times width times height. 9 by the base, 24 by 18. I won't ask anybody about that. 3,888 cubic feet. Ooh, now we're going to have to work now for the triangular prism. Capital B is the area of the triangular base. So let me highlight it for you so you can talk to me. Here you go. What's the area of this triangle, which is going to be capital B? Well, what's usually the formula for a triangle? 1/2 base times height. All right. What's the base of that triangle right there? Come on, talk here. What's the base?
18.
It is going to be 18. Everyone see where we're getting 18 from? Where the 18, even though it's down below. Yes, 18. 1/2 base. What's the height of that triangle? It's already there. 6. Yeah, that's what I was thinking. So here you go, kids. Here's the area of the base right there. 1/2 18 times 6. Ooh, and then we get nuts. H, height of the prism. What edge connects those triangles right there? That's what I'm looking for. What edge connects those triangles and how long is it? What do we got? Where's that edge and how long is it? You can do this one. That connects the bases. You can do that one. You can do that one. How long is each of them? 24 feet. So H times 24. Any issues getting there? Woo! Where is that there? 1,296. All right, so we got both prisms done. Yes! Total volume now. What's the volume of this room? Get my 3,888. Add that bad boy to 1,296. This room's got a volume of 5,184 cubic feet. Halfway home, right? Halfway home. Now figure out how many BTUs I need. No reason why we should be guessing whether I multiply or divide by 2.5 right now. No reason. No excuse. It's not. You're in one of two places right now. you 100% confident that you know if you divide or multiply. Or you're 50-50. If you're 50-50, set up a proportion from the conversion. Here we go again. 2.5 BTUs equal 1 cubic foot. There's the conversion. Make a proportion out of it. Volume goes with volume. 5,184 right here. How many BTUs is what I'm looking for? Makes it pretty easy if you multiply or divide now, if you solve this proportion. So what am I going to have to do? Divide or multiply? Multiply by 2.5. So going back here, 5,184 times 2.5. 12,960 BTUs. Awkward silence, awkward staring at each other. What?
You didn't ask anything.
I'm waiting awkwardly because I don't feel right now.
You have to add the Windows ones.
Feet cubed. These are BTUs. No, I'm not. I don't care about the label. Come on. This is awkward.
The room has the windows.
Yeah. How about those windows, right? Everyone thought they did a great job. That's how much just for the room, but how about the windows? Remember in the problem, it said for every window, I add in 1,000 BTUs. So we're not done yet. We still need to add in 4 windows, 1,000 BTUs. We still got to add in another 4,000. It's getting rough here today. 16,960 BTUs. There you go. How do you feel about? Let's go. How do you feel about that one? I know it didn't have. You're right. It had nothing to do with density, but I told you I threw volume word problems in here too. What do you got? Talk to me here. How's that one feel? Because I'm about to blow the roof off, literally, in this next one. Thought the house one was bad. How do we feel at home? How do we feel? All right? Okay, you ready to get after it now? All right, I have tissues somewhere. Yep, tissues are over there. You guys in class, if anybody needs to wipe away the tears. I don't have any Band-Aids if there's any bloodshed, though. You're just going to have to suck it up. All right, I got 500 bricks. Bricks in the shape of, I don't think I have to say this in the problem, but in the shape of,
Rectangular.
thank you, rectangular prism. Well, what if they are pyramid bricks? Just stop. Just stop being embarrassing. All right, these are rectangular prisms, bricks. I got 500 of them. That's the size in there, 5 by 1, 5.1 by 10.2 by 20.3. And then I got this trailer here, guys. But the trailer can only hold 900 kilograms. Can my trailer transport 500 bricks or not? And it's just not a yes or no. We got to show some serious work. And it looks like I gave you the density here, right? Ooh, that's nice. I gave you the density of the brick, of a brick, is 1,920 kilograms for every meter cubed. All right, guys. Here we go. Let's see if my trailer can pull 500 or not. What would it be nice to know if I have 500 bricks and I can't go over 900 kilograms? Yeah, how much a brick weighs? That would be nice. All right, because I have 500 of them. You're going to tell me something's wrong?
No, I just have a question, because like the dimensions of the brick.
Don't even say it. Don't steal my fire. All right, don't steal my fire. We're all good. I need to find out what's the weight of one brick. And what I'm going to use is the density formula. All right, I tried to warn you guys at the beginning of class, I'll mainly use the density formula to find the mass. So we're going to use the density formula. What's the weight of one brick? What's the density? 1,920 equals the weight of one brick divided by, all right, this is where your skills come in now. I need the volume of a brick. But not yet. There's a problem. When you find the volume of the brick, what units are you going to put at the end? You're going to put centimeters cubed, right? That's a problem. Look at your density. Your density is what? Meters cubed, right? Meters cubed. That's a problem. All right, they're not going to be in the same units. Does everybody see that? My density and my dimensions do not match. But they have to. So this is not an option, it's required. Change the units now. Do it at the beginning, not at the end. Change these centimeters into meters right now. And I should have typed this in as part of your packet, but 100 centimeters equals 1 meter. Are you okay why I'm changing it to meters? Because that's what the density is in, so that's what my units have to be in for the dimensions. Whew, what are you doing now, guys, huh? How do I change 5.1 centimeters into meters using that conversion? Oh, multiply, divide, right? Multiply, here we go again. Do I multiply, do I divide by the 100? Are you gonna take a 50-50 shot? What's up, Sophia?
Could you also find the volume of it in centimeters and then just divide that?
Because remember, I don't want you to do that, because here's why. Because this right here, just by doing this is not true, Sophia. That's not true. Okay, that's why I have you change it at the beginning, because this right here is a false statement. 100 cubic centimeters does not equal 1 cubic meter. All right, that's a false statement, so I ask you guys do it at the beginning. All right, what are we going to do? Divide or multiply by 100? I got to change 5.1 into meters, so do I take 5.1 and multiply it by 100 or divide by 100? I am going to divide, but I don't hear everybody saying divide, which tells me you're not too sure. Make a proportion. Put the 5.1 under 100 and put your x, the number of meters I need, under 1. And then as you guys cross multiply, you're going to see you have to end up dividing by 100 to get x by itself. So everyone right now, divide each of these centimeters by 100 and convert them to meters. Divide by 100. So 5.1 centimeters is 0.051 meters. 10.2 becomes 0.102 meters. And 20.3 is 0.203 meters. Now find the volume. Now find the volume of a brick. .051 times 0.102 times 0.203. We are finding the volume so we can plug it into density formula to find the mass. And you know my philosophy, we're not rounding anything until the end. Volume units have to match your density units. All right, so plug that back in now to your density formula. And let's find the mass of a brick. How are you solving that, by the way? How are you solving this? 1920 equals m over your volume. Cross multiply, yeah. You can put the 920 over 1, cross multiply. Here you go. Here's the weight of a brick. 0.275352. What units do I have now? Look at your density. How much does this weigh? Quincy? Kilograms. Good. I know it weighs kilograms because that's in the density formula. It's kilograms for every meter cubed. All right, so let's take it from here now. That's one brick. How many do I need in the trailer? 500. So what do you want me to do here?
Multiply by 500.
There you go. Multiply this mass by 500 bricks, and that should tell me if I can use my trailer or not. So times 500 bricks. And I think all of us should see the answer right away if I can transport it or not. 500 bricks is about what? 1,014 kilograms. So it looks like no go with my trailer, huh? Gonna have to find a bigger one. And then just write a little conclusion statement at the end, trailer will not hold 500 bricks. Because it could only hold 900, remember. Ooh, there it is.
So when it says justify your answer, you just need to write down
Well, justify is really your work. I'm going to look at your work. But I still need an answer at the end. Sophia, just because I see 1,014, I don't know what's going through your head if it's a yes or a no. So I need one concluding statement that finally says, no, he can't. Or she. Questions, comments? Okay. I did something that I have not done in a while, and hopefully I don't regret it. On Classroom, not only are the answers tonight, but also all the work associated with it. So you can see where my answers come from. Don't let me regret it by you guys just copying it down. And you guys can see, this is going to be a little tougher than usual. All right, so you got to buckle down a little bit and just not copy the work from Classroom. Got to be a little disciplined and be a little honors level kids too. All right, so you got the rest of the time right now. I'm not going to let you sign off at home, all right, because I want to be here if you have questions. Start the 3 problems that are for homework, please. Yep.
And that just to make sure, that first question, whenever it says a weight per in like measure of area,
Volume,
volume.
that's density.
That's the, okay, sorry.
Correct. So this is, exactly. This is what I was talking about earlier, Sophia. Did I say the word density in there anywhere? No, but what did you see on the units? Pounds, weight per cubic inch, volume. So there's the density. Bless you.
I think
Mr. Camino?
Yep.
On number 3, it says
Yeah.
the desired density of the shaved ice is, like, does it mean like the density of like a cone of shaved ice?
Just the shaved ice.
But like,
The whole thing, including that hemisphere there,
so it means
is
like a
getting
cone
filled
of
with
shaved ice,
shade.
okay.
Yes. Cone and hemisphere. Yep.
Number 2, should we use a rounded answer for propane?
Well, anytime you're talking about money, you should go near a cent, unless it says otherwise.
Well, yeah, but I mean the previously rounded, because in part A, you had us round to the nearest.
Yes, they keep using that. Yeah. All right, guys, keep working on those 3. I know they're going to be tough. We have another day of it. If you do need some small assistance, look at the answer key, please. All right, I'll see everybody tomorrow. Be smart, be safe.